Hello, so in this video we're going to work through an example and it's going to be the case where we have real distinct roots. So in other words, we should end up with two real distinct roots. So in other words, R1 should not be equal to R2. Okay, so let's try and solve this thing. So we've got y, second derivative of y, plus 5 times the first derivative of y, plus 6 times our function, and that's equal to 0. So in other words, what we're doing is we're looking for a form of y equals e to the rt. So we guess the solution is going to look something like that. Okay. In actual fact, very quickly, they don't always look like this. Okay. Later on in a few examples time or a few times, basically, if this thing on the right isn't equal to 0, then we have to be a little bit more careful about the choice which we're going to make. But for the moment, because this is equal to 0, let's just go ahead and just carry on using this. Okay. So first things first, we're going to put this thing into characteristic form or characteristic equation. Okay. And it's nice and easy. The way which I do it. So if I just let me write this thing out again, so we end up with y double dash times 5y dash plus 6y equals 0. Okay, the way which I do it is I just simply say, right, okay, I'm going to replace this here by a 2 and this to an r. Okay, this here is going to stay as a 1 and this here is going to change to an r. Okay, and this here, because this here is just going to disappear. Okay, so that's my characteristic equation, and you can kind of hopefully see, effectively I want to make it look like a quadratic, which I have done successfully. Okay, and now it's just a case of solving this thing. Now I can solve this thing, I can factorize these things. Okay, so to me it looks like r plus 3 and r plus 2 is going to work. Yeah, because look, if I multiply 3 and 2 together, I should get 6. That's right. And if I add these two things together, so 3 plus 2, I should get 5, and that's right. So I do. So this thing's work. So in other words, what I end up with is that I end up with r1 equals minus 3 and r2 equals minus 2, just by looking at those two things. Okay, so that's just solving a quadratic. Okay, I've been doing that since GCSE. So in other words, what I can say then is that my first solution is going to be, well, it's of the form y equals e to the rt, so it's going to be y1 is equal to e to the r1 times t. Well, r1 is minus 3. Okay, r1 is minus 3. Okay, and my second solution is going to be y2 equals e to the r2 times t. Well, my r2 is minus 2. Okay, so therefore this is going to become minus 2 times t. So those are my two solutions. And then my general solution is going to look y is equal to some constant, c1, times my first solution, so e to the minus 3t, okay, plus c2 times my second solution, so e to the minus 2t. Okay, so that is now my general solution. Now let's suppose I get given some initial data, so some initial information. So say, for example, I get given the information that when t equals 0, so when I set t equals 0, I end up with my function, so y of 0 is 2, okay? And the first derivative of my function is 3. So in other words, this is like initial data. So in other words, I've got my, I know this initial data, or I've been given this initial data. Well, I can use this initial data to work out what my constants are, so C1 and C2. I can work out these constants just by using this initial data. Okay, so let's do that. So in other words, I know that when, so y of, I know that y of t is just that thing, is equal to C1 e to the minus 3t plus c2 e to the minus 2t. So that's what I know c1 is equal. So that's what I know what y is equal to. So in other words, when y is 0, so when t is 0, so t is 0, okay, I just replace t by 0 in all of this thing. So this is going to become minus 3 times 0, so this is going to become 0, okay, plus c2 e to the, this is going to become minus 2 times 0, so again, this is going to become 0. Okay, well, e to the 0 is just going to become 1. Okay, so that's just times 1. And I know that all that thing, so I know that y of 0 is equal to 2. So I know that all of that thing is equal to 2. So in other words, what I can say is that c1 plus c2 is equal to 2. So that's my first bit of information that I can use. Now, that's getting me a little bit closer to kind of finding out what C1 and C2 are, but I don't actually know what C1 and C2 is explicitly. So in order to find that, I need to use something else. So in other words, I want to try and solve a simultaneous equation, so I need to use this second piece of information. So in other words, the first derivative is equal to 3, and when set it is equal to 0, so when t is set is equal to 0, then it is equal to 3. So in other words, if I find the derivative of this, which remember is just basically that, I just put a dependency in, because of course this is dependent on t, because what's my variable? Well, c is a constant, e is a constant, minus 3 is a constant, c2 is a constant, e is a constant, minus 2 is a constant. That's my thing that can change. So the t, so that's my variable. Okay, it's the thing which can change. All right, so let's go ahead and differentiate my y. So I'm just going to use that for reference. So y dash of t is equal to what's the derivative of this thing? Well, c1 stays alone. Okay, then I just need to find the derivative of this power and multiply by it. So it's going to be minus 3t differentiated is minus 3. So this is going to become minus 3 and leave the that alone. And then derivative of that thing, so it's going to become minus 2c2 e to the minus 2. Okay, and I know from this second bit of information, I know that this second bit of information, so when I set it equal to 0, so y dash of 0, that should be equal to 3. So let's do that. So I've got minus 3 c1 e to the, this is minus 3 times 0, so that's going to become 0. Okay, minus 2 c2 e to the, sorry, that should be a t in there. Yep. Minus 2 times 0, so that's going to become 0. Okay, so that's just going to become 1 now. E to the 0 is going to become 1. So in other words, what have I got? I've got minus 3c1 minus 2c2 is equal to 3. So that's my second bit of information. So I use that, and I try and solve out, find what c1 and c2 are simultaneously. So let's try and solve that. Now what I'm going to do is I'm just going to rearrange this. I'm just going to rearrange this to become c1 is equal to 2 minus c2. 2 minus c2. Okay, and I'm going to call that equation 1 and this one equation 2. Okay, so now what I'm going to do, is I'm going to replace equation 1 in equation 2. So in other words, I just have an equation involving c2, right? So minus 3 times c1, well what's c1? It's 2 minus c2. 2 minus c2, okay? Minus 2 c2, and that's equal to 3. Okay. So, right, okay, so now let's try and expand this out. So in other words, what I'm to find what C2 is. This is going to become minus 6 plus 3C2 minus 2C2, and that should be equal to 3. Okay, let's do a little bit of collecting like terms. So I end up with minus 6 plus C2 equals 3. Let's take the C2 on the other side. So end up with, or let's just leave the C2 there. Let's take the minus 6 on the other side. It's going to be 3 plus 6, which of course is 9. So I know that now C2 equals 9. And now I can use C2 equals 9 in C1. So C1 will just be equal to 2 minus C2, which I've just worked out as 9. Okay, so that's going to be 2 minus 9. That's going to become minus 7. So I now have C1 equals minus 7 and C2 equals 9. So C1 equals 7 and C2 equals 9. Okay, then I go up here and I find my original equation. Where are we? So this thing, and I just replace C1 with, what was it? It was minus 7 and C2 with 9, because now I know what C1 and C2 are. So therefore, that is my final equation. That is my final equation there. So no constants involved, and actually you can verify that if I plug that into my original equation, where are we? If I plug that into this thing, that it will come out as 0. It will come out as 0. So in other words, can't quite fit it on the same screen. There we go, that's a little bit better. So in other words, if I plug that, so I find the first derivative and plug it in there, second derivative, plug it in there, and I just plug that thing in there. And if I do that, if I plug it into that equation, it should come out as 0. You can verify that yourself.